Julian,
Yeah,
how are you doing tonight?
good. How are you?
Pretty good. I'm not sure I'm quite ready for it to be dark at 4 o'clock, but
Yeah.
not quite dark yet. I guess that's what happens on November 3rd, huh?
Yeah.
All right, let's see. I got this thing. So,
Can I go grab that real quick? It's upstairs.
yeah, go ahead.
All right. All right.
All right. So, question 1. They say which of the lines, if any, are parallel? Well, what do we need for two lines to be parallel?
They don't touch.
Well, that's one thing, but what else? In other words, that's a true statement. Those two lines are parallel because if I extended them forever, they would never touch. But what else is true about those two lines?
What's
the most important thing about a line?
I don't know.
It's slope.
Oh.
These two slopes are the same. So if two lines are parallel, then they have the exact same slope. Okay, so let's look at, hold on one moment. Let's look at line A, which passes through the point -1, 1 and 1, 3. That's line A. What's that slope?
2/2.
Good. So that slope is 1. Okay, now let's look at line B.
Okay.
What's that slope?
3/2.
Okay, don't do it backwards. In other words, make sure that you do the slope right. Slope is y sub 2. Remember, it's the changes in the y divided by the changes in the x. Now, in the first one, that meant 3 minus 1 over 1 minus a minus 1, which was 2/2, or 1.
Yeah.
What is it in this case? What is y sub 2 minus, excuse me, I wrote that wrong, minus y sub 1?
So wait, it's 4 minus 3?
No. What's the y sub 2 and what's the y sub 1? This is always x, this is y, this is x, and this is y. So take one of the y's, subtract the other y from it.
Okay, so 4 minus 2 is 2. And 3 minus 0 is 3.
Okay. So that slope is 2/3. So that line is not parallel to line A.
Okay.
Finally, let's look at this line. It goes through these 2 points. What's that slope?
3 and 2.
Hold on. What is y sub 2 minus y sub 1?
3? Oh wait, no, 2. 2/3.
Okay. So which two lines are parallel?
B and C.
Okay. And you can see how important it is to get the y's on top and the x's on the bottom.
Yeah.
If you get them backwards, you get the wrong slope. Now let's look at the problems on 2. So let's look at this line A, and this line is defined by this equation. What's the slope of that line?
Plus 12.
No? What's the general format for the equation of a line? Y equals...
mx plus b.
What's the slope part of that?
The mx.
Just the m.
Oh.
M is slope. So if we can turn this equation into y equals something x plus b, we'll know the slope. It'll be the coefficient of the x.
Okay.
So how would I do that? How do I turn that into a y equals something?
Do you divide it by 2?
Okay, what do you have when you do that?
Half x plus 6.
Okay, what's the slope of that?
1/2 x.
No, just 1/2.
Yeah.
It's not the x, it's the coefficient of the x. Okay, so that's the slope of A. Now let's look at the slope of B. Well, the equation for B is 2y minus x equal 5. So let's see if we can get that in y equal mx plus b format.
Alright, do you...
Solve that equation for y.
Alright. I don't know what to do.
Okay. If we're trying to solve an algebraic equation, this is really more algebra tonight than it is geometry, which I'm happy to see, actually. Because half of geometry is algebra, but it's good to every now and then get refreshed on your algebra. So if I'm trying to isolate this equation right here for y, what do I have to do? I have to get rid of everything that's not y.
Yeah.
What's the first thing that's not y on the left-hand side?
X.
Okay, how do I get rid of it from the left-hand side?
Plus x.
Okay, so now I have what? 2y equal...
5x.
Not 5x, plus x. 5 plus x.
Okay.
And then I can write that as x plus 5. It's no different. Let's do that because that's closer to this format.
Yeah.
Okay, I'm not quite there yet though. What's the last step in order to get this in y equal mx plus b format?
Divide by 2.
Okay, so what's that?
1/2 x plus 2.5.
Okay, yeah. What's the slope of this line?
1/2.
Okay. So A is definitely parallel to B.
Yeah.
Now let's look at one more. 2y plus x equals 4. 2y plus x equals 4. Solve this one for y.
Alright, minus x.
So the next line is
2y equals 4 minus x.
now what?
Divide by 2. 2 minus half x.
What's the slope of this line?
-3. negative half.
Uh-huh. So the only two lines that are parallel here are A and B.
Yeah.
All right. And that's pretty much the name of the game when you're trying to prove parallel is same slope. All of these are extremely fundamental algebra problems. This is almost the most fundamental thing you can do with an algebra problem is say, I'm going to give you the slope and 1 point, and I want you to give me the equation of that line. Well, with number 3, they don't give you the slope, but they do give you the 1 point. And they give you the equation, not of our line. If this was the equation of our line, we'd be done. Because that's what they're looking for, is the equation of a line. But what they want is an equation that goes through that point and is parallel to that line. So what does that mean, that it's parallel to that equation? What does that mean in terms of what we need? What's the slope of this equation that I've got the arrow pointed to?
So parallel, they have to have the same slope?
Yes.
Alright.
So what's the slope of this line?
Which one?
The one that I've written here?
Okay.
The one they give you?
Alright. Is it 2?
Uh-huh.
Alright.
So I can erase that. The only thing I need from that is its slope.
Yeah.
The only thing they've said is that the equation of our line is going to be parallel to this line. And the only thing that tells us is that the slope equals 2. Okay? So now I have the most fundamental of algebra problems. I have a slope and a point. What's the equation of this? What format should we use?
Y equals mx plus b?
We could use that, but as I said, we have a point and a slope. What's the other format you know?
I don't know.
Oh, well, maybe you and I haven't talked about this a lot. You have two primary formats.
Is it the Pythagorean theorem?
No, let's go over them. Slope-intercept is the y equals mx plus b.
Okay.
That's your slope, that's your y-intercept. So if you can get it into this format, then we could solve. But this is a little different. There's another format called point-slope. Are you familiar with that?
No.
Well, let me write it, and then you tell me again whether you're not familiar with it. You might not be.
I've never seen that before.
Okay, then we'll work just with y equals mx plus b.
Okay.
The problem actually is a little easier if you use slope or point slope format, but we don't need to. We'll use this one right here. Okay, so I want an equation that represents a slope of 2 and goes through the point 1, 3. Well, I have this much of the equation. I have everything but b.
Yeah.
How can I solve for b?
You plug in...
Yeah, exactly. What?
Yeah.
What for what?
The 1 for x.
And what for y?
3.
So I have 3 equals 2 times 1 plus b. And that allows us, because now we have one equation and only one unknown, I can very easily solve for b. What is b equal to?
1.
So now what is the equation that they are looking for?
Y equals 2x plus 1.
Precisely. Notice that that's quite different than the one they gave us, but only different in its y-intercept. This y-intercept was -5, this y-intercept was +1. So the first equation looks like that. Second equation has exactly the same slope but goes through a different y-intercept. This one is that equation. Okay, so that's what we're going to do to solve for these equations, is we're going to use the slope-intercept format and solve for b on every one. So let's do that here. Here, they say that our equation is parallel to this line. What's that make its slope?
2. Wait, no, -4.
And it goes through this point.
Okay.
We're looking for an equation that looks like this.
Okay.
How do I solve for b?
You plug it in, so 1 equals -4 times -2 equals b.
Plus b. Okay.
Alright, -4 minus 2 is...
Hold on. This is a very common mistake that you almost made there. That is not -4 minus 2.
Oh, yeah.
That is -4 times -2.
Yeah.
So what's -4 times -2?
8.
Now what's b?
9.
How do I get b?
I don't know.
Okay, the fundamental thing of algebra is that if I'm trying to isolate b, then I have to get rid of everything that's on that same equation line.
So you use -8?
Yeah. In other words, right now, b is being added to 8.
Yeah.
So I have to do the opposite. I have to subtract 8 from both sides of the equation. So what does that make b?
-7.
There you go. And now what is our final equation?
Y equals -4x minus 7.
Good. That's the equation they're looking for.
Okay.
Again, it looks very much like the one we're looking at. The only difference is its y-intercept.
Yeah.
But it has the same slope. Okay. What does perpendicular mean in terms of slope? Parallel means same slope. Perpendicular means what?
I don't know.
It's 2 words. Perpendicular means negative reciprocal.
Okay.
Well, if this slope is -4, what is the negative reciprocal slope? 2 things you have to do. You have to take the negative and you have to take the reciprocal.
Alright, so the negative?
What's the negative of -4?
+4?
Correct?
Alright.
What's the reciprocal of +4?
+4.
1/4. Reciprocal means you flip it. In other
Alright.
words, if I have 4, it's really 4 over 1. So if I take the reciprocal of that, it's 1 over 4.
Okay.
Okay, that's what reciprocal means. So the perpendicular line to this equation from the last problem would be 1/4 x plus some b.
Yeah.
So that's what perpendicular means. Okay, so the next question, they say, which, if any of the lines are parallel or perpendicular? Well, the one thing we need is going to be slope.
Yeah.
So let's talk of line A. What is the slope of line A?
The slope of line A is -1 over.
Hold on. What is the definition of slope?
The change in y over change in x.
Oh, I love that. What's the change in y? That's a great way to remember it, incidentally. That's the same as rise over run,
Yeah.
but it's better. It's a little simpler, but it still doesn't get to the exact slope. We have to know what is the change in y. What's the change from 3 to -1, or from -1 to 3?
4.
Okay?
So 4
That was doing 3 minus a -1, right?
Yeah.
So the only thing you have to be very careful with is you go the same direction. You cannot switch up the directions now.
Yeah.
In other words, since we did 3 minus the -1, we cannot now do 1 minus the -2. That would be going in the opposite direction. So we have to do the bottom has to be -2 minus a +1. You can go in either direction, just so long as you go in the same direction. Now what is -2 minus 1?
-1.
Okay. I got a great program for you, Julian. I've been looking everywhere for this program. I finally found it about a week ago, and I don't think we've had a session since then. But I'm going to turn you on to it. I am going to copy that address and paste it over here in GoToMeeting.
Alright.
Can you see it in the chat window?
Yeah.
Click on that link.
Okay.
Should have opened up in a browser on your computer.
Yeah, I'll save it to my
Save it as a favorite.
Alright. Yeah.
That's for starters. And then come back to my desktop here.
Okay.
Let me show you how to use this best. First of all, don't worry about 2x1s.
Okay.
Okay? When you're practicing these, checkbox that, the 1x1 addition,
Okay.
the 1x1 subtraction, the multiplication, and the division. And the beauty of this website is that it works with positive and negative numbers, which is what everybody has troubles with. I don't know why it took me 6 years to find this program. You'd think that that would be the first one available when you look for digital flashcards, but it wasn't until just recently. So, tell me as fast as you can what the answers to these problems are.
Okay.
What's -1 times -12?
Positive 12.
Next problem. Oops, hold on. Just a second. Didn't take that. This is division.
Is it 6?
Okay, let's go through a little trick about the nines tables. Nine times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. Notice that the digits all add to 9.
Yeah.
If I go all the way up to 9 times 9, that's 81. That adds to 9. Any number multiplied by 9 adds to 9. So if I want to know, furthermore, not only when you multiply 9 times 3, the answer adds to 9, but the first digit is always 1 less than the number you multiply it by. So if I wanted to know what 9 times 6 was, I know the first digit's 5.
Yeah.
Second digit has to be whatever adds to 9. There's your nines tables all by themselves. Okay? Let's go back to this problem. 9 divided into 63 has to be what? Based on the reverse thinking. In other words, 9 times what is equal to 63?
7.
Yeah, that's how you do it. And after you divide, always, until you are 100% confident with your answer, multiply the 7 times the 9 to make sure you get the 63. Okay, what's this?
-2. -60.
Everybody does better on these when I give it to them in terms of flashcards than they do when they're solving equations. Do me one favor and do not use your calculator in these.
Okay.
These are meant to be done in your head, not with a calculator. That's their whole point.
Okay.
Calculators are great, but they ruin people's abilities to do single-digit multiplication, division, addition, and subtraction. So it's very important not to have the calculator available for this.
All right.
-1 plus -8.
-9. -44. Ooh, -5.
Okay, now you're questioning that. What's -5 times -11?
-55.
Well, it's plus 55. But it needs to be plus 55. If it's 55, then -5 is correct. If it's anything other than 55, then -5 isn't correct.
Yeah.
So when you say -5 with a question mark, it means you're not doing that step, which is to multiply that back times that to make sure it's that. Then, if you did that, you wouldn't have a questioning tone.
Yeah.
Okay, so let's try that on some of these. Now this is a little different. You don't necessarily do that same step here.
-4. -7.
Look at it again.
-1 plus 8. Oh, +7.
Let's look at why. When I add a negative number to a positive number, always subtract the two numbers. And then put the sign on the answer of the bigger number. Well, 8's bigger than 1,
Yeah.
so it's a plus. Whereas if I had 1 plus a -8, again, I'm adding a positive and a negative number. Subtract the two numbers. What sign goes on it? The sign of the bigger number.
Yeah.
So that's the way to do a negative and a positive being added together. Subtract them and put the sign of the bigger number. That means that's a 7.
-50.
You're not bad at these. I can tell that you don't need a whole lot of practice at this. But,
3.
yeah, here's the thing, Julian. If you're not 100% at these, it won't work.
Yeah.
If you have 95% accuracy, in other words, if I were to give you 10 of these problems, and let's say I'll give you 20 of the problems and you only miss one of them. That sounds pretty good. That's 95% accuracy. But you know what would happen if that was the case? You would use your calculator.
Yeah.
Right? Because you want to be correct. You don't want to, you don't want 95% accuracy. You want 100% accuracy. So 95% accuracy is not good enough for single-digit manipulation. You need 100% accuracy. So that's what we're shooting for, is 100% accuracy. Because otherwise, you'll just use your calculator when you're faced with these kind of problems.
Yeah.
And that's what we don't want. Mainly because algebra is just too hard when you have to use a calculator to do it. There's too many calculations. When you solve an equation, you generally have to do like 6 to 8 little tiny calculations.
Yeah.
What's this?
-9.
Good. But again, just because of your hesitation, I can tell that you're wondering whether minus and minus turns into plus. Well, that's only with multiplication and division, not with addition or subtraction. Well, if you're adding 2 minuses, it stays minus, always.
Okay.
Okay, so that's -9. All right, let's go back to our, well, let's do that one for me, and then we'll go back.
-6.
Good. In other words, we have -2 -4. What I suggest everybody does here is change our subtraction into addition.
Yeah.
Doing that. But then we have to change the sign on the term that was being subtracted. We were subtracting a +4 from this -2. Well, now we're going to add a -4 to -2. And when you set it up like this, nobody misses it. Everybody gets it. But when you set it up like this, half the people miss it. And that's no exaggeration. That, for some reason, mystifies a lot of students. I tell you why it does. It's because that's a negative sign, that's a subtraction sign. And people get them confused. In other words, all they see is a dash and a dash. And they think, well, they're both negative signs. But then they get confused, well, if we're subtracting a -4, that's what happens, I'm convinced, in most people's head. So always know that this problem is a -2 subtracting a +4, which we solve by making it a -2 adding to a -4.
Yeah.
All right. Close that out, reopen your sheet, and let's get back to this. Let's see, where were we? We were right...
I think on 5 or 6.
We were on 5. And we're trying to figure out whether any of these lines are parallel or perpendicular. And we've just figured out the slope of line B. Let's see, we figured out the slope of line A was, let's start question 5 from the beginning. Got waylaid with my arithmetic there. What's the slope of this line? We don't care what the equation of the line is, notice. We only care what its slope is, because they didn't ask about the equation. They only want to know parallel or perpendicular, so all we need to know is what that means for slope.
Yeah.
What was the slope of this?
4. over -1. Or no, 4 over 1. Or -3.
Okay, let's go through it. Because I know you know how to do the arithmetic now, so there must be something else going on. Let's label these. That's x1, that's y1. That's x sub 2 and y sub 2. And you can go in either direction. In other words, this is permissible,
Alright.
or this is permissible. As long as you go in the same direction, top and bottom. So what is my slope here?
4 over -3.
There you go. Equals -4/3. So that's the slope of line A.
Yeah.
What's the slope of line B?
3 over 4.
So there's the slope of B. This is the slope of A. What about those two lines, do you notice? Are they parallel?
No.
Are they perpendicular?
Yes.
Yes, because this slope is the negative reciprocal of that slope.
Yeah.
Okay, so first of all, A and B are perpendicular. Now let's look at C. What's the slope here?
4? Yeah, 4 over 3.
Okay, now you can't switch them just because the math is easier. In other words, you can't do, to get 4, you must have done y sub 1 minus y sub 2.
Yeah.
Well, then you have to do x sub 1 minus x sub 2.
-3.
Exactly, 4 over -3.
Alright.
Which is -4/3. So line C is what with regards to line A and B?
Parallel
To which one?
to A.
Okay. Number 6. What's the slope of line A?
-4.
That was easy. Line B. What's the slope of line B?
4.
Remember, you have to get it into slope-intercept format. That's the only one you've been taught. So we have to get it into this, and then whatever m is, that's our slope.
Okay,
So how do you convert this equation so that it's y equals something?
-2 from each side. And then divide by 4.
It's the slope of line B.
-2 over 4, or 1/2.
No.
Or
Y equals mx plus b. It's the coefficient of the x term that is the slope.
so x over 4.
The coefficient only. Not the x. The coefficient of the x. Well, is the coefficient 4? Wouldn't that look like this? Okay, 1/4.
Yeah.
That's the slope of line B.
Okay.
1/4, not 1 over B. 1/4. What is that relative to line A? Is that either parallel or perpendicular?
perpendicular.
Yes, it is. Now let's look at line C. We have minus 4y plus x equal 3. Do something with this equation so that we can figure out slope.
Alright, so minus x.
Okay. Now, I can write it like that, but it's better, since we're trying to get it in slope-intercept format, let's put the minus x first. First of all, you see that those are the same thing.
Yeah.
Minus x plus 3 is the same as 3 minus x. The only thing is it's better because it's closer to y-intercept. Slope-intercept format. Next step.
Divide by -4.
Okay. So what's the next line?
Y equals x over 4.
Good. And guess what? I don't care what that is.
Yeah.
We don't care what that is. This question has nothing to do with that y-intercept. It has everything to do with slope. What's the slope of this? What is the slope of line C?
1 over 4.
Good. What does that make it relative to our other lines?
Parallel.
To which one?
A.
B.
Oh yeah, B.
Okay. A was minus 4. And B was perpendicular to A.
Okay.
Well, if C is parallel to B, then it's also perpendicular to A. Notice that if you have two parallel lines, and you have a line that's perpendicular to that one, well, that same line has to be perpendicular to the other one also. For the same reason, that this slope is the same as this slope, and this slope here is the negative reciprocal of the first one. So it would have to be perpendicular to the second parallel line as well.
Yeah.
That's more geometry than algebra, but mostly tonight we're talking the same stuff I'm working with my algebra students. Okay, write the equation of a line that passes through the given point and is perpendicular to that given line. Well, so they're saying we need an equation that passes through this point and has a slope of what?
1 over 3.
The negative reciprocal.
Oh, so
1 over 3 is the same. You
yeah.
gotta do
So negative 3 over 1.
Negative 3 over 1. So negative 3 is the slope of our line. Now we have a point and a slope.
Yeah.
Well, here's the format we're looking for. And I can replace the m because I know it's minus 3.
Yeah.
So what's the next step?
Finding B.
Okay, how do I do that?
You plug in you plug in minus 3 equals minus 3 times 2 plus B.
Solve that for B.
Minus 3 equals, so minus 6, minus 9.
Okay, let's go through it. Don't try to do 2 steps in one. That's where you're getting caught up. Minus 3 equals minus 6 plus B. Now what do I have to do to get rid of the minus 6?
Plus 6. Yeah, I know. So positive 3.
And now what's my equation?
Y equals minus 3 plus
Hold on.
3.
Your final answer always needs a y and an x in it.
Minus 3x plus 3.
Okay. There's your final equation. In other words, we substitute that point But then we go back, once we've solved for b, we got to go back and put the y and the x back where they belong.
Yeah.
Okay? In other words, this equation works for every single point on that line. If I were to graph that line, it goes through that intercept. It has a slope of -3. No matter what point I pick on that line, I can pick a point down here, I can pick a point up here, I can pick a point there, I can pick a point there. If I plug in the x and y coordinates of that point, it's got to agree with that equation. That's what that equation means. It means that it is the collection of all x and y points that are on that line. So number 7, same problem, different numbers. Here's our point. What is our slope going to be of this one that's perpendicular to this line here? I'll even write the slope of the perpendicular to that is what? And that looks like a -3/5 to me.
Yeah, alright, so positive 3/5?
Negative reciprocal. Negative reciprocal. Always remember you got to do two things to it. You got to change a sign and you got to flip it. So flip it first. What is, after you flip it, what do you get?
5/3.
And now change it, well, you did both at once.
Yeah.
Okay, so that's fine, as long as you know that you have to do two things to get the perpendicular slope. You got to flip it and change its sign, because that was a -3/5.
Yeah.
Well, the -3/5 is the negative reciprocal of 5/3, just as 5/3 is the negative reciprocal of -3/5. They're both to one another. Okay, so now I got a point and a slope. Where do I go from here? Write everything you know about this equation.
Alright, so y equals 5/3x plus b.
Good. Now,
And b.
now what?
We have to find b.
Okay.
So 1 equals 5/3 times 6 plus b.
Now, don't do this all at once. Separate this. So 1 equals what? Multiply 5/3 times 6.
So is it 5/3 times 6/1?
Yeah, but let's talk about this, because there's a more efficient way to do this than it's this. 5/3 times 6/1.
Yeah.
And you could just multiply the numerators, multiply the denominators, and you get 30/3. Then you have to reduce that to 10.
Yeah.
But that's not the way to do it.
Okay.
The way to do it is to try to reduce this before you multiply. Notice that this is the same as 5 times 6/3 times 1.
Yeah.
Well, I can do something with the 6/3. What is 6/3 reduced to?
2/1.
Okay. Now, notice the problem solves itself. 10.
Yeah.
And I never had to deal with a number as big as 30.
Yeah.
If you multiply straight across, you're always doing arithmetic on bigger numbers than you need to.
Yeah.
So if you have to solve this without a calculator, if you have to solve it with a calculator, then you just do 5 times 6 divided by 3.
Yeah.
But that's not what I'd like to see you do. I'd like to see, in fact, every student I have, I would like to see them reduce that before they multiply. In other words, take that 6 and 3 and turn it into a 2 like that.
Yeah.
Then the problem really becomes quite easier. Not easier necessarily, but you're less likely to make mistakes. So B is, here, let's write the next line of this equation. We got 1 equals 10 plus B. So what's B equal?
Well, I see minus 10 from the side.
Okay.
So minus 9.
Good. And what's the final equation? Remember our slope was 5/3.
So y equals 5 over 3x minus 9.
Good. I think you got it. Write an equation of the line that passes through that point, 4, 2, and is parallel, and another equation that's perpendicular. So we're doing 9. Let's do the parallel part first. The point is 4, 2. What's the slope of the parallel part?
2 over... Wait, I'm confused.
Okay, we need the slope of that line that we're looking at there.
Yeah, alright.
So figure that out from the graph.
Is it 1 over 2?
Let's... No, it's steeper than that. But let's figure out how we're going to do it. How do we figure out the slope of that line? It's rise over run, right?
Yeah.
The problem is that I don't know what that value is right there.
Yeah.
Right there, it's on an intersection point. What's the
yeah.
y value right there?
5.
Okay. What's the y value right there where I can also know exactly what it is?
Minus 1.
Okay, so we have 5 minus a minus 1 is the rise. Now what's the run? From that point over to here.
2.
Okay. That gives us a slope of what? Based on that.
5 minus a minus 1.
Mm-hmm.
Four.
6. 5 minus a minus 1. Remember, this is your negative sign. This is subtraction.
Okay.
Change it into an addition problem. We change the subtraction sign, and we change the sign on what was being subtracted.
Yeah.
So now it's 6 over 2, or 3. Yeah. Is that the
Okay.
slope of that line, 3?
Yeah.
Is it a positive slope?
Yeah.
Line 9. That's not a positive slope.
Oh.
Let's review slopes. Let's review our signs on slopes. I'm going to draw a slope. You tell me if it's positive or negative.
Positive. Positive. Negative. Negative.
Okay, you know how to do that. What's the slope on that, positive or negative?
Negative.
So is our answer 3?
No.
What must it be?
Negative 3?
Yes. In other words, what we did accidentally, and this is really easy to do, is we took y sub 1 minus y sub 2. In other words, the first y minus the second y. but then we divided it by x sub 2 minus x sub 1. We took that 2 minus 0 instead of 0 minus 2.
Yeah.
So that's how we ended up with 3. Because it looked like 3, and that's okay. That's the correct number, and it's okay to do that as long as you recognize that that's going to be off by the sign. In other words, if you come up with a 3, then it's minus 3. Okay, so this is a little more difficult than a typical problem. A typical problem would give you the 2 points. Well, if I'd have given you the 2 points here, one of the points is 0, 5, right?
Yeah.
That's this point here.
Yeah.
This point down here is 2, negative 1.
Yeah.
So I really, if I'm going to do y sub 1 minus y sub 2 to get 6, then I got to do 0 minus 2 to get negative 2. So if I'd have done them in the right order, I would have gotten negative 3. But even if you do them in the wrong order, and you come up with a slope, just check to see whether you've got the sign wrong or not. In other words, there was nothing wrong with coming up with 3, but then I need to look at the picture and realize, well, that's a negative slope, so it must be negative 3. What is the slope of the perpendicular line? If the slope of the parallel line is minus 3, what's the slope of the perpendicular line?
Positive 3?
Negative reciprocal. You got to do 2 actions on that number.
So it's negative 3 over 1, so positive 1/3.
There you go. Okay, so they want the equation of both of these lines. They want the equation that looks like this, and they want the equation that starts out looking like this.
Yeah.
In other words, this equation down here is going to be our perpendicular, this equation is going to be our parallel. And our point is 4, 2. So let's solve this one here.
So 2 equals minus 3 times 4 plus b. So
Do that in 2 steps and tell me what you get for b.
alright, so 12 plus b,
Negative 12 plus b.
negative 12 plus b. So 2 equals negative 12, so 14.
Okay. So that equation is that right there.
Yeah.
The second equation, how do I solve for b?
2 equals 1/3 times 4 plus b.
What's b equal to? Do it in 2 steps. What do I have to do to both sides of the equation?
Minus 4/3.
Okay. Now let's solve that. How do you subtract a fraction from a whole number?
I have no idea.
You have to find a common denominator.
Oh yeah.
What's the common denominator?
2, 3.
In other words, I have to figure out how to write the number 2 as some number of thirds. How many thirds is 2 equal to?
2. Wait.
You see why it's 6/3?
Yeah.
Okay. So now I have 6/3 minus 4/3. That's what's going to be equal to b. That's 2/3.
Alright.
So the other equation is y equals 1/3 x plus 2/3. That's the equation of the parallel line. Excuse me.
Okay.
That's the equation of the perpendicular line.
Alright.
We came up with the equation of the parallel line. But the equation of the perpendicular line does have a positive slope. So it makes sense to have that 1/3 there, that positive 1/3.
Yeah.
All right, Julian, I got to go. I got a 5 o'clock, but this was good stuff tonight. This is stuff you absolutely need to know for algebra or geometry.
Okay.
Okay? Talk to you next time. Bye-bye.
Okay.